Assalamu alaikum wa rahmatullahi wa barakatuh. Today I'm going to talk about the introduction and problem statement for our assignment. First of all, this assignment is related to Newton's law of cooling. So we must start by defining what is Newton's law of cooling. It is basically describes the rate at which an exposed body changes temperature through radiation, which is approximately proportional to the difference between the object temperature and its surroundings, provided that the difference is small. The law is frequently qualified to include the condition that the temperature difference is small and the nature of heat transfer mechanism remains the same. In 2020, Chicano and Chuichi repeated Newton's experiment with modern apparatus, and they applied modern data reduction techniques. In particular, these investigators took account of thermal radiation at high temperature. As for the multi-methods Newton used, and they accounted for buoyancy effects on the airflow. By comparison to Newton's original data, they concluded that his measurement from 1692 to 1693 has been quite accurate. Newton's law of cooling has many applications, but in this assignment we use it only as an application of first order differential equations. And the formula used to solve this question is dt over dt equals to negative kt minus t naught. And then we have the problem statement. And this problem statement for this assignment is to use Newton's law of cooling and the formula associated with it to solve different kind of problems and know how to apply it to solve the first order differential equation using differentiation and integration technique. And that's it for my video.
In this assignment, methods of differentiation and integration techniques are used in forming equations to solve problems that involve Newton's law of cooling. This law is used to determine the time taken by a specific amount of heat flow. In mathematics, differentiation techniques are used to find the rate of change in a function. In this assignment specifically, it is used to find the variable rate of heat flow in order to determine the time taken. Since Newton's law of cooling states that the rate of cooling is always proportional to the temperature difference between the material and the surroundings, the cooling rate will decrease as the material becomes cooler over time. The equation used in this assignment is shown below. In this equation, K is a positive proportionality constant, which depends on the surface properties of the material being cooled. Since the temperature of the material is higher than that of the surroundings, T minus T2 is also positive. And since the material is being cooled, the temperature is decreasing, so the rate of change in temperature is negative.
My name is Tahir Sharif. This is manual calculations. The Newton's law of cooling formula, which is dt over dt equal k times m negative t. And then we integrated both sides, and this is separable equation. And then we used the initial condition to find a and k, and we used t0 to find a, and then we substituted by t1 to find k. And then we found the time at room temperature with the formula dt equal m plus ae power negative kt. And then we simplified to get the time of this. This is the results and discussions. As you can see from the graph, the Newton's law of cooling stated that the rate of cooling, which is the magnitude of the slope, decreases as time progresses. And this is the time of death, which is 98.6 degrees. And this is the time that they found the body. It was 80 degrees. And this is after the found by 1 hour. It was 75 degrees. And then this is the question. And this is the solution. Determine all the information given. The M is the constant room temperature, which is 70 degrees, and the T is the time, and the K is constant room temperature, which is 70 degrees, and the T is the time, and the K is constant, and TT is the temperature of the body at time, as we know according to Newton's law of cooling, which is the rate of change of a body temperature at a constant temperature M is proportional to the difference of temperature of body and its surrounding, M negative T. Therefore, the Newton's law of cooling formula, dt over dt equal k times m negative t, and by integrating both sides, this is the separable equation, we get that tt equal m plus ce power negative kt. And then we used the initial condition to find a and k, and the a was 10 and k is 0.693, which is 0.7. And then we find the time at room temperature, which is negative one half, which is negative 90 minutes, and it was 12 a.m. at this time. So the time of death is 1 hour and a half before the body was found. So the time of death is 10 and a half a.m. Thank you.
Conclusion. What we can conclude from this question is Newton's law of cooling have stated that the rate of heat loss of a dead body is directly proportional to the difference in the temperature between the dead body and its surrounding. From the equation, we can see that the temperature of the dead body have changed time by time. The temperature have been decreased as the time getting longer. From the calculation, we got the equation to find the A and K, which is T in the bracket T equals to M plus A exponential negative KT, based on the formula that we use, dt over dt equals to K in the bracket M minus T. The temperature of the dead body takes 1 hour and 30 minutes to drop from the time that the body is dead until the body have been founded, which is 70 degree Fahrenheit. So based on the solution, we have proved that the temperature of the dead body are decreased from the time that the body are dead until the time that have been founded. Appendix. In this question, we just use two equations to solve this question, which is formula of Newton's law of cooling and formula of separable equation. For formula of Newton's law of cooling, the equation is dt over dt equals to K in the bracket M minus T. And then formula of separable equation is T in the bracket T equals to M plus A exponential negative KT.